Okay, hello everybody. This is the first video. This is video 1.1 from AP Calculus AB Unit 1 video packet on limits and continuity. Okay, so this is a green packet. The page I'll be writing on though is white, so don't get confused because there's a white packet also. These notes are from the green packet and you should be writing along with me. I'm encouraging you to watch these videos with a classmate because then if there's something you don't understand, you could help each other through it. And if you don't understand something, you can rewind it. It's a video, so you could rewind it, you could pause it, and things like that. So don't just be a passive observer of these videos. Make sure that you're engaging, writing down the stuff. If you ever want to pause it and try to do the problems without me, that's something else you could do. So here it goes. This is the first video. Okay. I feel like it's a little blurry. Okay. All right, so video 1.1, you are supposed to be watching this video. Let me double check. Thursday 9/8. Okay. So what I'm introducing here is the concept of a limit. A limit in calculus. This is a definition that I just got from the dictionary, but it also applies, like this would be normal language, but the word limit, the same definition applies to calculus. The final, utmost, or furthest boundary. Okay, so guys, what I would like you to do is next to this definition that I just got like from a dictionary, I'd like you to write in these words. A number we can always get closer to but never pass. So I'm going to write that down. A number we can always get closer to but never pass. Okay? So today, guys, I'm going to be asking for you to identify limits, and we want to ask ourselves this question. What is the number we can always get closer to but never pass? Okay, so here we go. Directions. State the first number and the last number for each of the given sets, as well as its lower limit and upper limit. If the set does not have a first number or a last number, please explain why. Okay, so number one, here's the set. It's a closed set from -20 to 3. And I'm going to draw a number line down here. And this is my first video. I apologize that it's a little bit fuzzy. I'll make sure the other ones have a clearer picture. Okay, so we've got -23 closed set, so I'm putting filled in dots above the endpoints. Okay, so there's the set. The first number of this set, the leftmost number, it's definitely -20. The last number of the set, definitely 3. Now, when I'm thinking about the limits, the lower limit and the upper limit, so for the lower limit, I want to ask myself, within the set, so without leaving the set, if I keep traveling left, what is the number? Okay, so back up here to our definition. What is the number that we can always get closer to but never pass? All right, and the answer is, so maybe pause this if you want to try to figure it out. What's the number that we can always get closer to but never pass? Okay, the answer is -20, and I'm going to tell you why. So within this set, -19.9, that's pretty close to -20. But I can get even closer. I can stay within the set and get even closer to -20 if I go to -19.99. I can get even closer by going -19.99999. I can get as close as I want. No matter how close I am, I can always get closer to -20. But at the same time, I can never pass it and still remain within the set. So -20 is the lower limit. For a similar reason, the upper limit of this set is 3. 3 is the number that while traveling right within the set, I can always get closer to it but never pass it. 2.9, 2.99, 2.999. I can always get closer to 3, but I can never pass it. Okay, we have 3 more examples, guys. I'll go faster now that I think you have the idea. Or I hope you have the idea. Okay, so here is number 2. And let me fuss with something to try to... Yeah, oh, that's much better. Okay, perfect. Okay, much better picture. All right, so now I'm drawing another number line. Okay, -2, closed circle. Okay, from negative infinity to -2. Negative infinity is not a number. It is a concept that just represents something that never ends. Okay, so we just go left on this line segment. It's not a line segment, it's a line. But we just keep going left on and on forever and ever. That's negative infinity. First number, there is none. Oh, at the beginning, I didn't mention this to start, but DNE, guys, we're going to use to stand for does not exist. Okay, so the first number in this set does not exist. The last number in this set is -2. Now, in the directions it asks, it says, if the set does not have a first number or last number, please explain why. Okay, I'm just going to tell you why, but if you, I suggest you pause for a second and try to think about why yourself. But I'm going to say this. I'm going to say the first number does not exist because within the set, we can always go further left. Okay, so I'm going to write that down. All right. The first number does not exist because, well, I'm going to say it like this. I'm going to say because within the set, we can always go further left. So there can't be a first number. All right. So the lower limit, now we're going to think about the limit. So we're asking ourselves, what is the number moving left or right that we can always get closer to but never pass? There is no lower limit, guys. There's no number that moving left we can always get closer to but never pass. So it does not exist. Okay. The upper limit is -2. All right. Same reasons as number 1. All right. Next, 0 to 6. Okay, this is going to get interesting. Okay, so 0, 6, open circle, closed circle. Okay, a soft parenthesis means that we are not including the endpoint within a set. So 0 is not a member of this set. Okay, the bracket like this, square brackets, means that it is included. Okay, first number. Okay, they're actually, guys, the first number does not exist, and let me tell you why. I'm moving left on this. So 0 is definitely not the first number because 0 is not in the set. So what we have to ask ourselves is, well, if 0 is not the first number, then what is the first number right after 0 that would be in this set? And for example, I could say, okay, suppose I think to myself 0.1, like a very, very small number. 0.1, that's in this set. But that can't be the first number in the set because 0.01 is even further left. And guys, no matter how close you think you are to 0, you can always get closer. So there's no first number in the set. 0.000001 is in the set, but I can get an even smaller number that is also in the set. So there is no first number, DNE. Last number, 6. Okay, we've already seen examples like that. Now I have to explain why the first number does not exist, and I'm going to say this. I'm going to say the first number does not exist because within the set, we can always get closer to 0, but 0 is not in the set. Okay, so I'm going to say it like that. And if that doesn't make sense to you guys, you really have to try to, try to process that. Say it over and over to yourself. Try to digest it. Maybe try to come up with your own explanation. But I'm going to write it down. The first number does not exist. It looks awful. Does not exist because within the set we can always get closer to 0, but 0 is not in the set. I already wrote these notes out, so I keep looking at them. Is not in the set. Okay, so there's that. Now we've got to think about the limit. So the lower limit, guys, is the number within the set that we can always get, or actually it doesn't have to be within the set, but it's the number that we can always get closer and closer to but never pass. So moving left, what's the number we can always get closer and closer to but never pass? 0. And this is why I said things are going to get interesting. Previously, when the first number didn't exist, neither did the lower limit. When the first number did exist, the lower limit was the first number. Now we have a situation where the first number doesn't exist, but the lower limit does. Okay? 0 is not a part of this set, but it still is the boundary. All right, let's back up here. It is the final utmost or furthest boundary that we have while moving left in this set. Okay, last number, 6. Similar reasons as before. Okay, buds, one more. Now, if at this point you're feeling like, oh, I've got this because this is very similar to the other one, then you could just, you could you maybe like fast forward to the end of what I'm writing and then, just make sure that you agree with me. And this goes for all of the video lessons, guys. If you ever feel like, oh, I've got this, I don't need the explanation, you could fast forward, but still complete the problems, but you could jump to the end of my process and just see if we agree. And that's, I think that's good for you because it's gonna, you're kind of like venturing off on your own and then checking to see if you were right. I think that's good for your learning. Okay, first number, -1, lower limit, -1. If that doesn't make sense to you, back up to back up to number 1's explanation because it's basically the same. Last number, there is none. Guys, there's no last number for the same reason that this one had no first number. So if this doesn't make sense to you, you should back up to that explanation. The upper limit is 50. So when I'm looking for the upper limit, I'm asking myself, when moving right within this set, what is the number that we can always get closer to but never pass? It's 50. 49.9, 49.999, 49.9999999. I can keep adding 9s. I can get closer and closer to 50, but I will never pass it. All right. And now, why does the last number not exist? Very similar to this explanation. I'm going to say the last number does not exist because within the set, we can always get closer to 50, but 50 is not in the set. All right, so here I say the last number does not exist because within the set we can always get closer to 50. I feel like I need a comma there, but 50 is not in the set. Okay, guys, there it is. So at this point, let me see how long this video has been. This has been about a 14-minute video. Okay, I don't want you spending too much time on homework. All right, so depending on the length of these videos is how I'm going to assign homework. 14 minutes, about 15 minutes is not very long. And the homework in the homework packet that corresponds to this video lesson is about the same length as the page we just did. So I'm going to assign the whole page. So just a second, let me go grab that packet. Okay, so in the homework packet, so this is the white packet, the homework I'm assigning that will be checked tomorrow is on page 3. Okay, the entire page on page 3. And that is it, guys. That's our first video lesson. See you tomorrow.